Okay, folks, let us go farther with our discussion of, go further, I should say, with our discussion of nuclear chemistry. Last time we talked about the difference between nuclear chemistry or nuclear reactions and regular reactions. So when you see something like this, hey, consider the nuclear reaction in which U-238 becomes thorium-234. We see nuclear reaction, we automatically think what? That this is happening in the nucleus, that energy or particles are being emitted from my nucleus, whereas in a chemical reaction, it's all happening out in the electrons, right? Good. And we talked about our definition of a radioisotope. That would be an element with an unstable nucleus. And we said, hey, we have this process called radioactivity, and that's the process by which I take an unstable nucleus and it spontaneously disintegrates and it shoots out either particles or energy, and by doing so it becomes somewhat stable. And then we have radiation, and radiation is the stuff, right, that is emitted during the process of radioactivity. So let's move further and get into some details of radiation and look at this. Consider the nuclear reaction in which uranium-238 becomes thorium-234. Hey, that's pretty interesting. How do I go from uranium-238 to thorium-234? And then the question really is, what type of radiation is going on here, is exhibited? So what do we start with? We start with uranium-238. Now I'm going to write this in remember our old form of symbol YZ, where Z is my atomic number and Y is my mass number. So let's rewrite this uranium-238 in that form. And so what I would do is I have uranium-238. I look in the periodic table and I say U is 92. That's my atomic number. And it is somehow going to end up being thorium-234. My 234 goes here. My thorium, I look at the periodic table and I get a 90. Now, what's missing? I'm missing something here, right? Something has been spit out from my uranium-238 and is split off from my uranium-238 to leave me with thorium-234. Now here's the way we do this. We can look at the mass numbers as one equation where my arrow has an equal sign. So what do I have here? I have 238 equals 234 plus x. So let's solve for x. Even I can do this in my head, right? 238 minus 234 equals 4. So my mass number in my piece of radiation is 4. Let's look at my atomic number. I look in the bottom here where I have my arrow. I make it an equal. So I have 92 equals 90 plus x. So what does x equal in this case? Well, x equals 2. Good. So I have something that has 4 as my mass number and 2 as my atomic number. And when I look up to the periodic table, I see that with an atomic number of 2, I have He. So what has happened here? Let's clean this up a little bit. I have 238 uranium-92, which undergoes some type of radioactivity and emits some radiation, and I get 234 thorium plus helium-42, and this is my radiation that came out of my uranium nucleus. Now, what type of radiation is that? Well, we need to get some notes. So here we go. Let's talk about types of radiation. Radiation. Good. Types of radiation. Number 1, we have alpha radiation. Alpha. And sometimes alpha, they make this little funky alpha sign, which is like Greek, the small Greek letter A. Now, what happens in alpha radiation? In alpha radiation, 2 protons and 2 neutrons are emitted from my nucleus. So that means my nucleus spits out 2 protons and 2 neutrons. What's that do then to my atomic number? Well, my atomic number does what? If 2 protons are spit out, it drops by 2. What happens to my mass number? Well, remember, the mass number is defined as the number of protons and neutrons. If I lose 2 protons and I lose 2 neutrons, what happens to my mass number? It drops by 4. Excellent. Good. Now, what has actually been spit out? Well, we have 4 mass number, 2 atomic number, and if we looked at 2, we'd say that's He, and so what we say in alpha radiation is that a helium nucleus has been emitted. Good. So helium nucleus has been emitted. That's what happens during alpha radiation. Let's take a look at a second type of radiation, and I'm going to change colors now. Let's go with, what do you think? How about red? Red, and we're going to go with something called beta. Beta radiation, sometimes it uses that symbol. Now, what happens in beta radiation? Well, it's not anything really like alpha radiation. In beta, I have too many neutrons, and what happens is I have a neutron which breaks down, we'll say, into a proton and an electron, okay? But we're talking about inside the nucleus, so electrons don't hang around in the nucleus, and so what happens then? That electron is emitted from the nucleus. It's kicked out. Good. So, if we were to draw this, if we were to write this as an equation, we'd say I have a neutron going to a proton plus an electron. Well, my neutron has what for an atomic number? It has 0 because there are no protons. It has 1 for its mass number. I like to use the symbol H for my proton because a hydrogen atom without an electron is nothing but a proton. Some people use P. I tend to use H. It has a mass number of 1 and a atomic number of 1. And then how do I represent an electron? Well, in this type of nuclear equation, an electron is represented by 0 mass number and -1 for the atomic number. Good. So now this represents what goes on in the nucleus, right? In the nucleus. The proton stays, this thing stays in the nucleus, and my electron is emitted. It means it's spit out, right? Good. So what has happened to my atomic number? Well, my atomic number does what? I have a neutron that becomes a proton. Do the number of protons increase? Yes, they do. That means my atomic number goes up by a value of 1. What happens to my mass number? Well, I have a neutron, that's a part of my mass number that is lost, but I have a proton that's part of my mass number that's gained, so my mass number stays the same, is the same, right? And how do we represent, once again, in our nuclear equation? We use, as my particle, what we use as the symbol for that particle is E0 minus 1. Great, and we'll use that later. 3, let's go to the third type of radiation that I want to talk about, and that is called positron. Positron. Good. Positron radiation, positron decay is kind of the mirror image of beta. In fact, let's see. We have a proton which decomposes into a neutron and something we call a positron. Now, what's a positron? A positron is really a positively charged electron. So it has the same mass as an electron, but an opposite charge. It's what we call antimatter, right? The positron is antimatter of the electron. Now, what actually happens in the nucleus? In the nucleus, let's draw out this um, nuclear equation for what happens in the nucleus. I have a proton, and that proton is going to decompose into a neutron plus a beta particle, and there's my beta particle, but it's not a negative one, it's a plus one. My beta particle is emitted, it's shot out of the nucleus, and my neutron stays in the nucleus. So what happens in my nucleus here? My atomic number does what? Well, I have a proton that becomes a neutron. What happens to my atomic number, which is the number of protons? It drops by 1. What happens to my mass number? Well, I lose a proton, but I gain a neutron, so it stays the same. Good. And what is the particle which is emitted? The emitted particle is my E0 plus 1, which is a positron, right? Great. And then the last form of radiation that we talk about in this class is what we call gamma. Gamma radiation. Okay, let's move down here. We're going to need some space, don't we, to talk about gamma. So okay, here's gamma. So what is gamma radiation? Gamma radiation is really different than all three of these because gamma radiation is the emission of a high energy photon from the nucleus. Well, what's a high energy photon? Hey folks, a photon is really electromagnetic radiation. Electromagnetic radiation. And we'll learn more about electromagnetic radiation next chapter. But for us, here's what all we need to know. This is just a form of energy. So with gamma radiation, only energy is released. Only energy is released. What happens to my atomic number? Well, if only energy is released, what happens? It's the same. What happens to my mass number? Well, if only energy is released, it is the same. Excellent. Okay, this is not brain surgery here, right? Good. And how do I represent a gamma particle? Well, something along that lines. That's my gamma. I said particle, but there's really no such thing as a gamma particle. It's a gamma ray, right? So this is my ray, which is emitted from my nucleus. All right? Good. So I think we have the 4 types of radiation, and we can come back and answer our first question. What type of radiation is exhibited in this reaction? Well, when we look down here at the bottom, what do we see? I start off with my uranium. I end up with my thorium. What has been spit out of the nucleus? We have helium-42, my helium nucleus. What type of radiation spits out a helium nucleus? It is what? Aha, it is alpha. So, what kind of radiation do I have going on here? Alpha radiation, alpha decay. So that's answer number 1. Let's move on and take a look at some more questions related to radiation. And these will go quickly. So here we go. Consider alpha decay of beryllium-9. Okay, alpha decay, that's a piece of cake, right? We know that an alpha particle is what? It is a helium nucleus. Good. It's decay. That means it's going to be on the other side of my yield arrow. It's spit out, and I start with beryllium-9. I look in the periodic table, and what do I see for beryllium? I see 4. Good. And I need to figure out what's left over here, right? So what do? I look up here at my mass numbers, and I have 9 equals 4 plus something. So when I take 9 and subtract 4, 9 minus 4, 5. So I have a 5 here. And then I do the same thing with my atomic numbers. I have 4 is equal to 2 plus what? 4 minus 2 equals 2. So I have 5, 2, and I look in my periodic table. When I have an atomic number of 2, that means I have helium. There we go. What is the resulting element? Helium-5. Piece of cake, isn't it? Good. Let's see what you can do on your own. Here it is. Consider alpha decay of thorium-230. Write the nuclear equation for this reaction. Okay, just put me on pause and work this out. And when you have an answer, bring me back to life. Okay. Well, good. I hope this is not a piece of cake. I hope this was a piece of cake for you. We have alpha decay, right? That means I'm going to spit out a helium nucleus. What do I start with? I start with thorium-230. I look in my periodic table. Thorium is what? 90. And then I just start doing some basic math. 230 is equal to 4 plus my unknown. What's my unknown? 226. 90 equals 2 plus my unknown. My unknown must be what? 88. I look on the periodic table. 88 is what? Radium. Good. So this would be my nuclear equation. I have thorium-230 that's going to radium-226, and it spits out an alpha particle. Perfecto. Let's go farther. Beta decay. Okay, what's beta decay? Let's go back, look at our notes. Beta decay. Well, here's beta decay, right? And what do we know about it? I have a neutron, which becomes a proton, and an electron. The electron is emitted out. What particle do I use? I use this guy to represent beta decay in my nuclear equation. So let's use that. Beta decay of, beta decay of carbon-14. I spit out a beta particle. We said it's E0 minus 1. What do I start with? Carbon-14. Carbon-14. I look at the periodic table. Carbon is 6. Good. So what do we have going on here? I have 14 is equal to 0 plus. What must my plus be? 14. I have 6 equals -1 plus my unknown. Now, okay, people, we got to be careful here. We often make some mistakes here when I see this -1. How do I get that -1 on the other side? I add +1 to both sides, right? So that becomes 0, that becomes 7. So my question mark is equal to 7. 14, 7, look on the periodic table. 7, what do I have? Nitrogen. So here is my nuclear equation that represents the beta decay of carbon-14. Can you do that? I think that you can. There you go. Beta decay of thorium-234. Put me on pause, and when you're done, bring me back. Okay. Piece of cake, right? It was easy. Well, I hope so. Beta decay, what kind of particle is emitted? Well, it's going to be an electron, and we represent the electron with 0 minus 1. What do I start with? Thorium-234. I look in the periodic table. Thorium is 90. So 234 is equal to 0 plus what? 234. 90 is equal to -1 plus what? Okay, 91. And so that is what? Pa? Yeah, how many of you think that is Pennsylvanium-234? Well, that would be wrong. Pa is not Pennsylvanium. Pa is protactinium. And so what element is produced? Protactinium-234. Great. Let's see how much time we've used. Ooh, almost 20 minutes. I think this is a good place to stop. I'll catch you next time, and we'll talk in more detail about positron and gamma. Ciao.